We're ready to start coding up a sensitivity analysis of exponential decay in the context of first-order chemical kinetics. We've already set up our data product called sensitivity analysis, and it contains our pipeline folders of an input, protocol, incremental, and product folder. And since this particular exercise is motivated by first-order kinetics, I've put the slides from the derivation of first-order kinetics that I did in a previous video. So if I open up this slideshow, we'll see the slides where I worked through the materials of deriving an exponential decay from the differential equation defining first-order kinetics. So ultimately, we want to have R help us play around with this equation and look at what this model looks like, especially if we change values of the parameters like the C0, the initial concentration, or the decay coefficient, or the decay rate coefficient, here specified with a Kr. So this is the equation we want to work with. And ultimately, in order to do that, we want to be able to predict what concentrations we'll see over time. So if we're thinking about something like a batch reactor where we have a chemical reaction occurring, we want to think about how the concentration of a reactant is changing over time. So with that in mind, let's minimize PowerPoint. Go back to our pipeline, go to our protocol, and start up R with our Studio project file. So here's our RStudio session. Again, we've got our File tab. We're in the working directory of the protocol folder in our pipeline, and we have our console window ready to take commands. If you recall, R is called a scripting language because basically the programs are a script that you could just type into the console if you really wanted to. That's not going to be practical in most cases, but it's possible. So we can start learning R simply by typing into the console some of the commands that you might use in your script. One of the more basic things that you can do in R is assign values to variables. So the assignment operator in R, I'm going to use the variable name x, and I'm going to assign a value to x, which is the less than symbol and a dash forming a little arrow. And let's just say I'm going to assign it the value 2. Now you'll notice things have changed up in the upper right. In this environment tab, I now have a variable that's defined in my global environment. That's the environment that variables are going to show up in by default when you assign them from the console or in your program. So we see the value, or the variable x now has the value of 2 in memory. So RStudio is telling us that the value of the variable x is 2. But we can also look at that directly through the console. We have access to our workspace, and if we type the variable name in our console by itself and hit enter, it's going to tell us a summary of the value of that variable, which in this case is simply the value 2. Note that this is the same thing as calling the print function on the expression name of the variable, which is x. So if I do a print on the expression x and hit enter, it will give me the same thing. It will tell me that the value of that variable is 2. That's because these are basically doing exactly the same thing. Now, one thing to note about variables that you might assign through the console is that those values are in RAM, which means they're going to disappear if we lose this context of this RAM. So if I close this R session and I close down that workspace, and then I bring back up RStudio again, notice that that global environment is empty. So it cleared that RAM. It's not there anymore. And if I type X at the console, it can't find it. It said object X is not found. So this is the nature of RAM. It's temporary memory. It's not going to necessarily be there from one session to the next. And this is actually a really common cause of error in R programs, that if you put something into the environment through the console that isn't being put into the environment by your program, then it's not going to be there the next time you bring up R. So if you have a program that depends on something that you manually put into this environment, that program's not going to work if you restart R. So we'll talk about that more later, but it's important consideration in R programming. There are a few functions that you can use in the console to explore what's in the global environment. For example, there's a function called ls, and that will let you list the variables that are in the global environment. If we don't give it any arguments, it's going to look at the global environment, and in this case, it's empty. If we re-add our x variable with a value of 2 to our environment, and then we do an ls, now we can see that we have the variable x in our global environment. And if we had more variables, there would be more character strings of names of variables in this particular data structure. Another function that's useful is the exists function. The exists function allows us to ask R whether a particular variable exists or not. So in this case, I'm going to give it the character string x because I'm asking whether the name character or the variable name x as a character string exists in the global environment or not. So if I hit enter, it'll say that it's true. If I say that does the variable y exist, it will say false. That variable does not exist. So that's just a quick way to figure out if a variable that you need is actually there or not. Finally, you can remove things manually from memory using the rm function. It's short for remove. So I can call rm on the variable name x. And you can see x has disappeared in the graphical interface. If I type x, it'll say it's not found. Or if I type exists on x, it will now say false. So those are just a few functions that you can use to explore the global environment for different variables. As a quick review, we've talked about variables being organized within environments. In our case, we've been changing variables in the global environment, and that allows us to give a name to a space in RAM and give it some value. We used the less than with a dash as the assignment operator to assign some sort of object to a variable. In this case, that object's a numerical value. Note that the operator equals is also going to work in R typically for this case, but the equal operator actually means something subtly different than the assignment operator, and in some cases, equal is not going to do quite the same thing. So I prefer to use the formal assignment operator of the less than and the dash just to be consistent. And then you can type the variable name in the console to see what the value of that variable is or see a summary of the value of that variable. We also talked about the ls function telling us what variables are in the global environment. And finally, we talked about the function rm that will let you remove a variable from the environment, and the function exists that will let you check to see if a variable is present in the environment.